Dr. J.D. Armstrong. I'm the Maui Technology Education and Outreach Specialist here at the University of Hawaii Institute for Astronomy. And it's my pleasure to introduce today's speaker, Dr. Joe Ritter. And Joe has been kind enough to give me a script so that, unlike most times, I hopefully will not make any mistakes. So Dr. Ritter chairs the Maui County Outdoor Lighting Committee and is spearheading an effort to retrofit streetlights while reducing light pollution. He's the laboratory director at the Institute for Astronomy Maui Advanced Technology Research Center, so here. He received his PhD from the University of Miami in 1998. His current research areas include adaptive optical systems under the NASA Innovative Advanced Concepts Program, nanotechnology, metamaterial design, and other fields. His background includes research in plasma physics, space telescopes, radiative transfer theory and measurement, satellite remote sensing, and space propulsion systems. It gets better. As if it could. Previously, he was the team lead as the NASA Marshall Advanced Optical System Development Group, associate research scientist in the Space Systems Engineering at Florida Space Institute, and an associate development engineer at the University of California, San Diego's Center for Astrophysics and Space Research. All right, and that covered, did I get everything? Joe, did I get everything?
You got everything. Yeah.
Okay, yes. But I also know that Joe does a lot of work outside of these fields, so he's actually being modest. So let's give him a warm welcome. We really appreciate him giving this talk.
Thank you, Dr. Armstrong, for the lovely introduction, and for inviting me to speak tonight. It's my understanding that I have some colleagues and there are other people actually all over the globe right now. So I bid you a virtual aloha to those out in cyberspace watching this, and to all of you here. Welcome to the Pukalani University of Hawaii Institute for Astronomy Advanced Technology Research Center. Thanks for coming tonight. I see in the audience some friends, some Nikilo Huko, watchers of the stars. I see some biologists. I see some reporters. So I better watch what I say. Pukalani, our center here. Pukalani is a Hawaiian word that means what knowledge we gain from the cosmos, or what knowledge we gain from the heavens. If we can't see the stars because of light pollution, what knowledge can we gain? Tonight's talk is about light pollution and light solutions. So who am I to, I didn't realize I'd have the full intro, so who am I to tell you about light pollution? So I chair the Maui County Outdoor Lighting Standards Committee. I'm a scientist, I'm a physicist, and in particular my PhD involved a lot of work in atmospheric radiative transfer theory, so that means I know about light and how it propagates in the atmosphere. I've had many faculty appointments in astronomy and space systems engineering, even animal science, and there will be a little bit about animals tonight. And et cetera, I know about energy and lighting and environment and stuff like that. So that's why I'm here speaking to you tonight. There we go. First of all, what is the Maui County Outdoor Lighting Standards Committee? It was established by an ordinance. It's part of the Maui County Code. It was established in 2006. It is made up of experts in lighting, Hawaiian culture, wildlife biology, astronomy, and public members. It serves only as an advisory committee to the county, and specifically to the Department of Public Works. Our committee only makes recommendations. It has no teeth. Maui County Public Works makes decisions. These decisions must follow county ordinances. LED, that is light-emitting diode lights, are coming all over the world. They eventually, no doubt, will come here, and therefore there's a current need for a new ordinance. What is light pollution? Well, the definition from the International Dark Sky Association is that is any adverse effect of artificial light introducing sky glow, glare, light trespass, light clutter, decreased visibility at night, and energy waste. Light pollution obscures the stars at night. It interferes with astronomical observatories, and like any other form of pollution, it disrupts ecosystems, so we're particularly sensitive to this on Maui, and has adverse health effects, not only for animals, but potentially for humans as well. It is one of the most rapidly increasing forms of environmental degradation, and the levels of light pollution globally are growing exponentially. Light pollution is synonymous with energy waste. Over-illumination is the excessive use of light. So you'll find tonight I'm going to ask you some questions, but I'm also going to define a lot of things. I'm really pleased to see the public coming. I hear a lot of people go, yeah, that light bothered me, but I don't really know about this, and so I'm pleased to see that you're interested in light pollution and showed up tonight. In the United States, lighting energy accounts for about overuse, and over-illumination from lights accounts for use of, at minimum, 5 million barrels of oil or the equivalent per day. And that's just from light that is wasted. That contributes to light pollution. Energy audit data shows that 30 to 60% of energy consumed in lighting is gratuitous. It's not needed. People overlight. You can see the Earth from space from a long distance. You don't need to. Over-illumination is responsible for, I already put 2 million, I messed up my view graph. Okay, well, anyway, so Maui County is particularly sensitive environmentally. We have night-flying endangered birds. We have turtles. We have one of the best astronomy sites on the planet. And there are issues with these new blue-white LEDs. So what I'm going to discuss tonight is suggested for legislation coming up for the county. And the proposed changes not only help the environment, but can save Maui over $1 million a year in energy consumption. And with that, changes will happen. LED lights probably will come here, but it's imperative that these changes are done carefully and responsibly. So, a few view graphs to give you an idea about light pollution. We're very lucky out here. We have relatively dark skies. Here's a night view from a city showing the impact of sky glow. Here's a very similar view of the night sky at a dark sky site. Tremendous difference. In fact, if you go to Oahu, you simply can't see anything like this. Here's a similar view of the sky from a location well away from the city. And if you go up to the top of the mountain, you can often walk around just in the starlight. I'm going to show you some examples of light pollution before I tell you what we can do about it. Here's Kihei viewed from Kula. There's a tremendous amount of sky glow coming up from Kihei. Here's Kahului from Pukalani. This is an example of light pollution and light trespass. Light trespass is when light goes to another place where it's not intended, where you don't want it. It's preventable, it's reversible, and all of Maui can benefit with having reduced light trespass. So, why does Maui need a better outdoor lighting law? There's a tremendous, and here's a picture, let's see, I think this is Kihei? Yes. Drive by that every night. It's Tesoro, that's right. So there's a tremendous amount of light trespass on Maui in common areas, in private areas. We need to improve standards for LEDs. We're certainly interested in energy conservation because I'm a taxpayer. All of you are taxpayers, most of you. A few of you are too young. We have a tremendous amount of glare and clutter, and tonight's talk is primarily about public awareness. So I'm going to define a number of things for you. What is visible light? And this is a question my students ask me often, and I've kind of wrestled with this for a while, and I'm going to try to give you my concept of light. I won't tell you all of the physics behind it, but visible light is electromagnetic radiation, where you have a wave that's propagating in space, and it has, if you look up in the corner here, an electric field oscillating in one direction and a magnetic field oscillating in another direction, and it makes this bundle of energy that kind of oozes and propagates. That's my definition of a photon. So visible light is electromagnetic radiation that's visible to the human eye, and it's responsible for the sense of sight. Light has properties, for example, intensity, direction it propagates in, the wavelength spectrum, or the color of the light. And visible light has a wavelength. And we're going to use the term wavelength a lot tonight, so I'm going to tell you what it is. So here's a little picture of light, and the wavelength is the distance between the two peaks on these waves, much like it would be in the ocean. The wavelength is associated with color. So shorter wavelength is bluer, and longer wavelength is redder. It's just another form of light, just like X-rays, gamma rays, ultraviolet rays, except our eyes are not sensitive. In this case, the light is too short a wavelength for us to see, and here, infrared light, radar, television, the wavelength is too long for your eyes to see. So I'm just going to talk tonight about the visible light spectrum unless people have questions about other spectrums. Okay, what is the spectrum? I should have defined it first, probably. Well, it's a measure of the power contained in different wavelengths, that is, different colors from a light source. All of you who have ever had a copy of Pink Floyd's Dark Side of the Moon will probably recognize a prism here, or maybe you've just seen a prism, or maybe you've held a CD up in the light and seen the light get split into rainbows. So a spectrum is a measure of the different power in the different colors of light. The amount in the red, the amount in the blue, at different colors, at different wavelengths. Why is it important for astronomy? Well, I'll give you one example. In astronomy, we do remote sensing. We measure things from a distance. We can tell about the chemistry of stars or planets from millions, billions, even trillions of miles away. And it works like this. Here's a star. In this case, let's pick our star. Here's a planet that has a sodium-rich atmosphere. And what we do is we take the light that we receive on Earth and we put it through a prism or a grating, and we spread it out, much like the prism up here does. There will be certain lines that absorb the light, and these are characteristic of certain elements. So by looking at absorption, or in fact emission, we can actually tell something about the chemistry of an object that is billions of miles away. And to me, that's just fascinating and intriguing. That's one of the reasons why I like astronomy. Okay, another definition. What is a full cutoff fixture? A full cutoff fixture is a lighting fixture where no light is directed up above the horizontal. If you look at the street lights on Maui, some of them are like this, some of them are not. Some of them are being repaired. We unfortunately still have a lot of street lights that will direct light up into the sky. When I'm driving on the road, that's not particularly useful to me. In fact, that's a terrible waste. A good design of a full cutoff fixture doesn't have a whole lot of light at high angles. That way, when you're driving towards the street light, you don't get blinded. So it's nice to have nice even illumination, not a lot of light at high angles, and no light above the horizontal. So these are all properties of desirable lights. Okay, some more bad lighting examples. Here's a rural country road with tons of unnecessary lighting and glare. And I'm sure all of you have seen things like this. It's terribly wasteful, and in fact, because these have reflectors, in order to get a lot of light out here, far away from the light, you have to really crank up the intensity beneath the light, so you get hot spots. Sports lighting complexes. We have one just across the road, and there's a tremendous amount of light that comes from that, and it gets directed upwards. Here's an example of, sorry, I'm having trouble with my clicker tonight. Here's an example of sports lighting from Kihei, but viewed from Kula. Most sports stadium lighting doesn't use full cutoff technology and doesn't set limits on its time of operation. I know when I was a graduate student, we had a telescope, and it was right next to the sports stadium, and I was always at 1 in the morning calling them up saying, "Can you please turn off your lights?" And they said no. So of course, I couldn't do any astronomy there. Here's an example of safety lighting. People think you need light at night to be safe. I won't debate that point at the moment. But a lot of safety lighting has a lot of glare. And so, in fact, you can't see the people if you're a person in a car driving towards them. You can't see details. Here's an example of a full cutoff fixture where you can see the people clearly and you don't have glare. More light does not mean you're safer. More light is not better. Adequately lighting and doing it without glare and uplight, that is what's important when you design a lighting system. So good light, not more light. You've all seen these on Maui and driven past them. I hear a couple gasps in the audience. So they have these portable generators, and you drive by and you're blinded by it. Perhaps not the best way to light temporarily on a road. What is good security lighting? I showed the picture 2 view graphs back. You should always have full cutoff fixtures. You should have good uniformity. It should be automatically controlled to save energy. You should only make as much light as you need. Again, bright security lighting doesn't prevent crime. Good lighting is what you're looking for. Essentially what I'm saying is to put the light where you need it. And I'm just going to show a last example here of undirected bright light. So you have a lot of glare here. I guess there's somebody hiding over in the shadows here, so that's not very secure. You get these big shadows. It's about contrast. Your eye typically has 1 billion to 1 contrast capability, but only 1 million to 1 at any time. And so you really need to have uniform lighting. As I said, LEDs are becoming prevalent around the United States. And in fact, I talked to somebody yesterday in Holland, all over Europe. They're coming all over the world. Why should you use or not use LEDs? Well, many people say that LED lights produce light more efficiently. That's actually not always true, but you can direct the light more efficiently. So what we have now for street lights are, on Maui, are what are called HPS, high pressure sodium. And so high pressure sodium and mercury fixtures, they have a gas discharge bulb and then a reflector above it. And so because it's not a focus starting at a point, you can't direct the light well. It's spread out. Your reflectors tend to, the lateral fall off is bad. So if you go off to the side from a light, the light drops very rapidly. And so you also have losses from the reflectors. And because of all these problems combined, as much as 30% of the light that you make is wasted, not to mention they're too bright underneath and not bright far away from them. So in order to ensure that minimum light levels are at the midpoint between luminaires, that is, if you have 2 street lights, and you want to have some minimum light level in between them on the road, the overall light level must really be cranked up. And all of a sudden, we're making a lot more light than we need if we did it carefully, and so it's bad and it contributes to light pollution. A lot of this light will hit the ground and bounce back up. Good directionality of light emitting diodes allows light level to be reduced by 25 to 30%, actually possibly more, and you can still have the same good lighting and the same functionality for your lights. So again, efficiency means putting light where it's needed and only where it's needed. So again, why use or why not use LEDs? Well, the coverage of well-designed LED luminaires is vastly superior in a couple of respects. So I won't go through everything that I have on the view graph here, but basically you get very uniform lighting, and I will demonstrate this to you a little bit later. Ultimately, when you use LEDs that are designed well, less light's directed skyward, and that's a good thing. LED fixtures then provide better visibility and less glare, and they use less energy. But there's a problem. There are these blinding blue-white LEDs, and you probably have all seen them. And I personally get very irritated by them and have headaches and things when I'm under them, but that's just me personally. But the point is there are a number of environmental impacts. And so I'm going to make the case tonight, try to convince you that LEDs can be good, but you must not use blue-white LEDs. Okay, this is not the colorblind test I had up earlier that some of you commented on. This is actually a human phobia. And so these are individual receptor cells that are in the back of your eye. And so I have red cones, green cones, and blue cones shown here. And the first thing I'm going to point out to you is that in the central fovea, where you do your very high acuity vision, which you need for seeing fine detail and you need for rapid response, as opposed to your nighttime blue cone, your blue rods, there are no blue receptors in the very center of the fovea. The brightness you perceive in your eye is a function of the red and green that you see here, and light that's picked up in the center of your eye. The color is partially a function of the red minus the green, and it's also the blue minus the red plus green. And this is, I put this up because this is actually how the neural network in your brain processes the information to get color from these. The red cones outnumber the green cones 2 to 1, and the red and green cones outnumber the blue cones 10 to 1. Here's a plot of the human photopic vision sensitivity. That is the vision you have when something is illuminated, not when you're dark adapted when you've been sitting in the dark for a long time. And here I've plotted on the bottom wavelength, it's cut off a little bit, and here relative sensitivity. You see that the human vision peaks in sensitivity in the green and the yellow. It's very, very poor in the blue. We have very low blue sensitivity in the human eye. The human eye color sensitivity is not exactly the same, but it's related. And again, you have a peak near the green and yellow. We have very poor color sensitivity in the blue and also out in the near infrared. Okay, why am I telling you all of these things? Well, let's see, maybe I can block this and ask you, why is the sky blue? Welcome. Yes, Aaron.
Because when the light from our sun enters the atmosphere, the blue light is what's not absorbed and what makes it to our eyes.
And why isn't it absorbed as much at your eye? Do you know that? Well, it's because it scatters a lot in the atmosphere. And so I promised to only have one equation tonight for you. And so blue light, again, is a shorter wavelength, and red light is a longer wavelength. And the scattering efficiency of light is inversely proportional to the wavelength to the 4th power. This is a phenomenon called Rayleigh scattering. It's a first-year graduate student physics exercise to say the sky is blue, how many atoms are in your chair? So this is the odd kind of thing and believe it or not, you can go from one fact to the other, and this is what physicists do. So what I've done is I've plotted this equation, and as you can see, in the green and blue, you have a tremendous amount of light scattering, and in the yellow and red, you have far less light scattering. Why is this important? Any light that makes it up into the sky, whether it's from being directed upward or even with a good light hitting the ground and then bouncing back up off the pavement or a sidewalk that goes into the sky, can get scattered. If you have redder light, it is much less likely to get scattered, and so it can go a long distance and not come back to you. If it's blue light, it will scatter a lot. And that's, again, why the sky is blue. So we just see blue everywhere because of the Rayleigh scattering phase function. Okay, so some spectral considerations for lighting. First, I'm going to point out, again, photopic sensitivity. It's this curve right here with the shortest blue arrow. And this is where the human eye is sensitive. Here is a blue-rich LED, so this solid line here. And you note that a lot of the power is where the human eye is fairly insensitive. This is wasted light. Human eyes are very poor at judging blue light. There are lots of reasons why blue light is, that's going to be my theme tonight. Blue light is bad. If you take anything away from this. However, you need some blue light if you're going to have color rendition and see the color blue. It also turns out, and I'm going to hit this again later in my talk, that melatonin produced in the human body that regulates sleep cycles and things like that, melatonin is suppressed by blue light. And so here in dash is the melatonin suppression curve, which almost exactly overlaps with these blue-rich LEDs. This is a serious issue health-wise, and I'm going to talk about it in a little bit. So, if you want to make a light, you have to look at these things. Again, light pollution adversely affects wildlife, human health, the Maui economy, and astronomy. And just for fun, this is a slightly altered graph, but I'm going to point out that a lot of animals don't see exactly what we see, and you may be aware of this, that reindeer can see in the ultraviolet, and that some pigeons are pentachromic, that they have 5 different receptors in their eyes. What I've got here is just, here's a dog's eye sensitivity, and normalized to that is a human eye sensitivity. And so again, we're pretty good in the yellow and green. Dogs are not. Dogs see really well in the blue. We do not. And there are differences in many species, including birds, and we'll talk about that tonight. Endangered wildlife. Okay. Why is blue light bad? Well, here's my little bird illustrating this. Estimates by the U.S. Fish and Wildlife Service on the number of birds killed after being attracted to tall light towers range from 4 to 5 million birds per year. Some estimates are order of magnitude higher. I'm trying to be conservative here. That's a lot of birds that get killed. Light sources that look similar to stars, that is, light sources that have a lot of blue light, confused endangered species night-flying birds and our endangered sea turtles, and this little bird up here is very confused. And what happens is they see a blue light post that's tall. They will often circle round and round until they drop and die of exhaustion. I didn't know that. Yes. Moths are attracted to light too. I don't offhand know the spectral sensitivity curve for the moth, but they certainly do, and birds orbit as well. I don't know all of the reasons, and I don't know a lot about moths. I know a little bit, and I'm kind of interested in butterfly wings as well, and iridescence. And that may be another lecture I give you another night. So this has gotten so serious that over in Kauai, in March of 2010, the Kauai utility was sued over endangered night-flying seabird deaths. And so they were having sports games, they had bright lights, and there were bird takes, and birds died. And so another question for you is, could this happen on Maui? Please repeat questions. Yes, sure, JD. Will do. Will do. Okay, and so part of the point here is that this is an endangered species bird. Blue light confuses the birds. Here are a couple of endangered species that we have on Maui, the Newell shearwater and the dark-rumped petrel. And in fact, the U.S. Justice Department notified the Kauai Interscholastic Federation 6 years ago. They were in violation of the Endangered Species Act and the Migratory Bird Treaty Act. Local officials on Kauai failed to take any action on this, failed to install shielded lights that shine down on their field, and their failure to do so has resulted in a number of endangered species deaths. Kauai County will be fined for every bird that dies from this point on by the federal government. Pardon me? I can't answer that. Maybe Mike could. It's been a while. So March of this year? Okay, so it's been a while, and so they will be fined every time an endangered species bird is killed because of that. Dr. Armstrong, yes?
Repeat the questions for the audience in
I got
the
that.
virtual audience. Oh, okay.
I got that. Thank you. Thank you. So this happened in Kauai. As a taxpayer, I hope this doesn't happen in Maui. And as an environmentalist, I hope this doesn't happen in Maui. We don't have a great clicker tonight. There we go. Okay, I'm a scuba diver. How many of you are scuba divers or snorkelers? A lot of you. Okay, so you see the beautiful honu, the turtles. I love seeing them. I stay away from them. The honu, the Coloniomydes, the green sea turtle, is a very beautiful creature, I think, and the populations face a very high risk of extinction. And it's because of several factors. And worldwide, these factors include a probable population reduction of more than 50% over just the last decade. In the Mediterranean, the population is critically endangered. In the Eastern Pacific, Hawaii and Southern California, they're designated as threatened, not endangered yet. In specific Mexican populations, they are endangered. The Florida population is endangered. So we're sort of at a critical time right now to do something about this. I certainly hope we don't have endangered turtles here. I hope we have lots of turtles here. How does this happen? So while I was looking at lights a while back, I took this picture on Lanai. Here's a mother turtle that was up on the beach. We don't know if that evening she was going to try to lay her eggs in the moonlight. But what happens is turtles lay eggs on the beach. The surface albedo of the water, that is the surface reflectance of the water, is higher than that of land. And so before we had artificial lights, if you were by the ocean, it looked brighter out over the ocean because of stars and the moon and things like that. And so the turtles evolved and learned to go towards the light when they hatch, when they're little babies about half the size of my finger. Now that we have light inland, and a lot of it, and the sky glows, what happens is the little baby turtles, when they hatch, they go the wrong way. And a lot of them die because of that. So light pollution affects a number of endangered species out here. And the point is, blue light is bad, and our turtle friend here, blue light confuses me, just like the birds. A number of people have asked me about health, and I've talked to some biologists and a number of medical researchers about this. And as I mentioned earlier, blue light suppresses melatonin production in humans. So there are a number of links that are suggested to cancer because of melatonin production. And so rather than just saying this, on this page and next page, I'm going to list a dozen studies that suggest that this is absolutely true. There has been a link to melatonin production drops in creating breast cancer, for example, all sorts of tumors. Not to mention blue light, when it suppresses your melatonin, your sleep cycle gets disrupted. Here's a paper that I looked up, and it was again about circadian photoreception. So this is the graph I showed you for suppressing melatonin production and tumor biology. And so there are some serious health issues with lights with a lot of blue in them, not just for endangered species, not just for astronomers, and not just a significant issue for biologists, but there are potentially severe human health issues that go along with these. Now, these are being put up all over the world. It's time that we talk about some of these issues. Okay, now we do astronomy here. So I'm going to tell you a little bit about astronomy in Hawaii. We have absolutely the best observatory sites in the world. Even Haleakala sometimes has the best conditions on the planet. Statistically, it's about third best in the world, the best spot being over on the Big Island. We have the best observatory sites. We have the Institute for Astronomy where you are, and this is just part of a large distributed institute. This is just what we have on Maui. And we have strong international partners and work on leading telescope projects. And, of course, our new Pukalani Center here. We care about light pollution. Let me say something about Hawaiian tradition and native Hawaiians. The Nikilo Hoku in the past were people who watched the stars. And it's my understanding that in the Hawaiian culture, the science and astronomy and religion and cultural beliefs are very intertwined. And I have a lot of respect for these beliefs. Hawaii's indigenous people were astronomers. They navigated here by the stars. using non-instrument navigation on the open ocean is an amazing skill. I've tried to do it to get home fishing. I've gotten close. I don't think I could go across the Pacific Ocean. And it's a skill that is almost lost in our culture. And it's very important to the native Hawaiians. In Oahu now, you can barely see the stars. Have any of you been to Oahu recently at night? No. Yes? Could you see any stars? Yeah, you would hope, without all the lights, you could maybe see 5,000 stars with the naked eye. You're lucky if you see a couple. It's really changed over there. And this could happen on Maui, and I hope that it won't. And while we're on the subject of cultural things, I'm just going to have a very brief mention here about King Kalakaua, who, aside from being a statesman and a lawyer, he was also an astronomer. And he invited the British to come and do surveys here and encouraged astronomy. And it's worth taking a moment to read this quote. And what King Kalakaua said is that it will afford me unfeigned satisfaction if my kingdom can add its quota toward the successful accomplishment of the most important astronomical observation of the present century. He was talking about the transit of Venus expedition. And assist, however humbly, the enlightened nations of the earth in these costly enterprises. If we're going to be an enlightened nation, maybe we need to have not too much light. There is no Pukalani, there is no knowledge from the cosmos if we can't see the stars. So, again, the best telescopes need the best sights. And why is it so great out here? And that's a question I'm often asked. And that is, the mountaintops are high enough in altitude to be above a thermal inversion layer. And so you've probably seen this. Often you get the clouds cut off at about 7,000 feet. Not always. You almost never see the 50,000-foot thunder towers here because the nice, clean laminar flow across the ocean will come and shear those clouds off. And so we don't get a lot of the giant storms. I don't know of any tornadoes here. I've certainly never witnessed one. We have low humidity and low dust because of the inversion layer. And, very important, we have dark skies. We have low light pollution. And here's a picture of Haleakala. And it's unfortunate, but in this beautiful place, when you look down at Kahului, you see the sky glowing now. A little more on astronomy. This picture was taken where it was very dark. This is what you can see when it is absolutely dark. This is the Hubble Deep Field. So on Maui, every % increase in white light pollution that we get has the effect of effectively reducing the size and the collecting area of our telescopes by the same percentage. So as we have more light, we can do less astronomy. And one of our treasured national resources and local resources, our dark skies, are disappearing. We have a project here called Pan-STARRS, and the project is designed to locate asteroids and comets that are Earth-crossing objects that could collide with Earth. When I had the privilege of starting off this lecture series about 4 years ago, some of you, I know were here, I gave a talk on asteroid and comet collisions. So the university, one of the things they've done is build a telescope system where we can locate asteroids and comets that could hit the Earth. And so if we can't do these observations, if the skies are not very dark, I have to ask the question, could we miss the next dinosaur killer that wiped out civilization? And that may be going a little far on this, but you get the point. We don't want to destroy astronomy here. Some of you may be aware that this year's Nobel Prize in Physics came from our dark skies in Hawaii. This was a discovery based on supernovae that was about the universe not only expanding but accelerating. This would not have been possible to make this discovery in science that's changing everything and confusing a lot of people if we did not have dark skies here. So I'm going to talk a little bit about how to make a good light. And there's always changing technology. But even with new technology, spectral requirements for good lighting are dictated by the laws of physics. There's Rayleigh scattering, and so this is what I was talking about where blue light scatters a lot more. There's the spectral energy distribution of the night sky, that is what the sky glow is. And there's the sensitivity curve of the human eye. So I'm going to talk about a particular technology tonight, but one thing that has been proposed for Maui County is to have a technology-independent standard, so that as technologies progress, we can still design lights that are spectrally sensitive, but with whatever technology for the future. And my last point, none of these points, the physics, the darkness of the sky required for measurements, or Rayleigh scattering, will change. These are constants. 100 years from now, when we have lighting panels from Star Trek, we will still be looking at the same requirements. Here's an example of light pollution viewed from the Big Island, from Mauna Kea, from almost 14,000 feet. It's viewed through a grating. A grating, in this case, is a transmissive grating that will split the light into different colors. So here from the mountaintop, you can see Waikoloa Village. You can see areas on the Big Island, and in fact, you can see Honolulu, nearly 200 miles away. Light pollution, for example, light pollution standards in California had requirements in the past for low-pressure sodium lights 30 miles away from, or within 30 miles from telescopes. But in fact, light pollution goes hundreds of miles. Here from the same mountaintop, you can see Maui, and in fact, quite a bit of blue light coming from Maui. And so the transmission grating splits the light you see into the colors that make it up. So there's quite a bit of blue light from Maui, and then here's actually, I don't know where this road is, but the point is, even at the top of one of the darkest sites in the world, the best telescope site in the world, there's a tremendous amount of light pollution. So we're really going to ruin our dark skies if we aren't careful. Light pollution can affect our economy on Maui. From a tourism standpoint, it's important to keep our skies dark. It's just as important to keep them dark as it is to keep our beaches and water clean. We can't kill endangered species, wildlife. We need to have turtles people can go and see. And as a taxpayer, I'm pleased to see that over the next decade, astronomy will bring into the economy in Hawaii a minimum of $1.4 billion in jobs and infrastructure to the state of Hawaii. This is very clean, green economy. These are jobs that are high-tech. These are jobs that are construction. These are things where you operate with a minimal footprint. And so astronomy is very important just to our local tax base. My figure here is old. In 2006, I know there was over $142 million in high-tech economy on Maui alone. I'm just kind of guessing that it's still over $100 million a year. I don't know for a fact. So, but years ago, it was quite a bit. All right, so we've seen all these problems. How can you solve these problems? It's great to go, well, we don't like light pollution, we care about endangered species, but what are you going to do about it? Well, I went through an exercise 2 years ago where I said, gee, LEDs are coming, there are problems, how do we design a good light? Well, the first part is to make a light and make light of a color that is useful. So again, here you have to look at the human eye sensitivity curve. You want to make a light that puts light only where it is needed. You should make it full color. You should make it energy efficient. Very even illumination, unlike yet it must require spectral compliance. So these are the components that go into designing a good light. I'm going to show you a light in a few minutes where only 10% of the light is in this high scattering region, and 90% of the light is in a low scattering region. A light where 90% of the light is where the eye is very efficient, maybe 6.5% where light scatters a little more, but you get color rendition and only a tiny bit of blue light. Now, I personally would prefer no blue light, but it's been a debate for over 20 years on Maui. What kind of lights to use? And law enforcement on Maui has suggested that they need to have good color rendition, and they claim that it is a factor in safety. I'm not going to get into that debate tonight. I think the astronomers would like to have no lights, or lights that are low-pressure sodium, like we have out in the parking lot, which we can turn on later if anybody's interested in seeing them, where you have very poor color rendition. Well, this has been going on for 20 years, and so what I've tried to come up with is something that will make everybody happy, where we have very low scattered light, we have good sensitivity, yet we can have good color rendition so that everybody in the county can be happy. So this would be sort of a win-win compromise, hopefully. A little bit on different types of lights. So I mentioned LPS. This is low-pressure sodium. They are the pink lights that you may have seen on the Big Island and in very few parking lots here. They have very poor directionality. They use a fair amount of energy. They're not bad. The maintenance is very high. The bulbs last 1 to 3 years, and after a couple months will be down to 70% of their original output. Their color rendition is very poor. You can't see what color anything is. The color rendering index, and I'll define that in a few minutes, is something like 5. Environmentally, they're very good, but some people don't want them. High pressure sodium, HPS, is what we have now for streetlights all over Maui. Directionality is very poor. They use a lot of energy. Maintenance is very high. Again, these bulbs will burn out in 1 to 3 years, and the amount of light substantially reduces after the first few months. The maintenance is very high. You've got to send a guy up a pole. It's probably a few $100 to do that, plus the cost of the bulb. Color rendition is not bad. It has a color rendering index of something like 24. You can tell what color things are. I don't particularly like the color rendition with them, but they're environmentally very bad. They have a lot of blue light, and for disposal, they have a lot of mercury. And so they just go in the landfill. So I'm sure we've all had some of it to drink. There are white LEDs. Fortunately, it's not methylmercury, but mercury is not a good thing. There are white LEDs, and they have very good directionality and less energy consumption required. Very low maintenance, very good color rendition, but tons of blue light. And they would devastate astronomy on Maui. They would be devastating to our night-flying seabirds and other endangered species. They would be devastating to turtles. And there are very clear human health effects in a number of studies. So white LEDs are very bad. You may have seen amber LEDs. And they're very good, but you can't see colors, and you can't see blue very well. And a number of colors you can't see all that well. But they're environmentally very good. In working with the county, we've discussed the possibility of something called spectrum-compliant lighting, where we have good directionality, low energy consumption, very low maintenance, very good color rendition. In fact, a color rendering index of over 50, so twice that of the current lights that we have now, so hopefully the law enforcement on Maui would be happy. Yet they have very low blue light, and so they're environmentally very good. And so this is what we hope will be the change that happens on Maui. Okay, some definitions. A good spectrum. What is a good spectrum? Well, I'm going to tell you what has been proposed for the new Maui County legislation before I show you an example of it. The relevant spectral range we will talk about is 380 to 700 nanometers. So that is from very blue, near ultraviolet, but not quite ultraviolet, so the limit of blue vision, out to 700 nanometers, the far end of red human vision. Spectral power distribution is, I could read this, it's the power per unit area per unit wavelength of an illumination. But essentially what it is, it's how much power you have at each color. And there's a very clear, well-defined way to measure this so that it can be a part of law. We define blue fraction as the light that is bluer than 500 nanometers, and the blue-green fraction as light that is bluer than 550 nanometers. This is the high scattering region. The sun is what color? Come on, am I putting you to sleep? What color is the sun? Yellow. Okay. Because the sun is yellow, I can tell that the surface of the sun is about 6,000 degrees Kelvin. The correlated color temperature of a body is a number that describes, if you had a glowing black body, what temperature would give off this color distribution. Okay? So the correlated color temperature of a light that looks like the sun would be around 6,000 Kelvin. The color rendering index, and we're almost done defining things. I just want you to understand what is going on in Maui. The color rendering index is a quantitative measure of the ability of a light source to reproduce colors of various objects faithfully. And so if you want to tell what color a perpetrator's shirt is, as the police do, then, or what color your car is in a parking lot, or things like that, then you want a good high color rendering index. Okay, so what we've recommended is what we call spectrum compliant lighting, and I've broken this up so you can see it a little better, so that only a few percent, again, 3.5% or less of the light is in the blue, 10% or less of the light is in the blue and green, and 90% of the light is where it does a lot of good, where the eye is very sensitive, yet it won't scatter a lot. But just enough of the evil blue color that you can still see colors with the human eye. And so this is what has been proposed to go into new legislation in the next couple of months in Maui. And it satisfies the police requirement that has a very high color rendering index, greater than 50. And again, this is twice what we have right now with the kind of pinkish high-pressure sodium lights we have on the streets. The requirement is color recognizability by normal, unimpaired, non-colorblind people. And to be able to go, hey, that's red, that's orange, that's yellow, that's green, that's blue, that's black, that's white. So, this new type of light is very environmentally sound. It's acceptable to astronomy and to the wildlife community. It has far better color rendition for the police. It puts light where it's needed, so less light needs to be generated so that we can reduce light pollution. Maintenance is cut drastically, and the estimates are that if we implement this for all the streetlights on Maui County, we will save over $1 million a year in electricity, and also the associated pollution created by generating that electricity. A byproduct of all this of less blue is there's less Rayleigh scattering, and there's less light pollution per lumen. Okay. So my statement is we probably will have LEDs. They must be spectrum compliant. They must not be white LEDs, and white LEDs are very bad. Yes, you have a question, Aaron?
With the lights that they built, well, do they have a design yet for them?
I'm going to show you one right at the end of the talk. And there are actually a number of companies that have made some that are like this. So what can you do about light pollution? Well, most of you may have lights at your house. If you're by the ocean, I certainly hope that you have full cutoff fixtures. You can set a good example. You can use full cutoff and not white lights. You can learn more about good lighting. I'll be happy to talk to any of you about this. And I'm hoping that the county council will support a spectrum limited outdoor lighting ordinance. And for those of you in the virtual world, perhaps you can support such a lighting ordinance wherever you live. So, in summary, to LED or not to LED, that is the question. So with careful informed choices, we can save $1 million a year on Maui in energy, we can save sea turtles and endangered birds, we can save astronomy in our dark skies, we can reduce light and air pollution, we can be good public stewards of our island, and I think all of us want to be, and I think the people in the county want to be as well. We should have efficient LED streetlights, but only with spectrum compliant lighting. So what I'm going to do now is I'm going to stop for a minute for questions, and then I'm going to ask you all to participate in an exercise where we look at one of these lights. So thank you all for coming, and I'll take questions for a few minutes. Yes?
What percentage of light emitted in neon is blue?
It depends. Well, so real neon in a neon light is actually red when it glows. Okay, so there are what are called neon lights, and then it depends on the gas mixture. And any light is different depending on its gas mixture. Aaron? Aaron's our future physicist here that's been showing up. So.
If you make new street lamps so that well, not near future, but the far future, will they be more efficient than our current ones?
The time has come now, and far more efficient. Efficiency is an odd thing to measure. So you also can produce less light and light better. And so the real question is, what would the energy savings be with comparable or superior lighting? And the answer is you would save over half of the energy, and that's conservative. It's considerably more potentially. Yes?
The acronym ESL, LED.
Mm-hmm. It's an efficient spectrum limited light.
Are the current lights retrofittable?
There is also a company called EcoScience Lighting that will be producing some of these. But are they retrofittable? Absolutely. Absolutely. Yes?
That was part of my question. I have a two-part question.
Yeah.
One of the questions was, I assume it's going to be costly to exchange them, but if they're retrofittable, then I guess it's less costly. But who will pay for that?
Well, that's a very good question. So if you look at their costs and you amortize it over their lifetime, they actually pay for themselves and more in energy savings. There are different ways to do it, and it's a great question because people in the county who spend our money as taxpayers will go, well, where's the money coming from? So there are a couple of options. One way is for them to just put up the money and then save it for years. And with the very low maintenance and with the energy reduction, they would pay for themselves very rapidly. There are also companies that routinely finance things like this, so county can do this kind of thing for nothing and not get as much of the savings. Some of it goes to this company that puts out the loans, right? So effectively, you can do this for free. Yes? Oh, sorry, you had a second.
That's one of the questions, because clearly we have this problem all over the world, and
Yes.
in the rest of the United States. Is it being dealt with in other big cities and other places around the whole country, or is it just Maui that's doing this right now?
It's a great question. So Florida has excellent lighting laws, and they have great restrictions there. San Diego, I've been talking to people in San Diego who interact with the city council there. They are going to have a new lighting ordinance soon. There are a lot of places where people simply don't know or don't care, and white LEDs will be put in. It's my hope that anywhere there are endangered species or sensitive coastal zones, and that's a good part of the world. In fact, most of the world's population lives by coasts. I'm hoping this will get, something like this at least, will get adopted. You know, my original intention was for Maui, but there are places, you know, for example, in Qatar, they have beautiful turtles that are endangered. People there care about it. People in Holland that I talked to and did emails with yesterday, they care about it. I know a number of astronomers in Mexico that have expressed interest. As soon as we knew about this, they go, wow, we didn't know this existed. And the fact is, until now, it didn't exist. And so I hope that we can help. Yes? So the question was, can this be used, I guess I forgot to repeat all these questions. Can this be used as airport lighting? And the answer is, it would be wonderful for airport lighting. Previously, there was new airport lighting suggested for Maui, and they were very bright and white, and that would have been very bad. These would be far, far better. And so, absolutely, this is a scalable solution. You can make as much light as you want, but again, you don't have to make as much light to have very good illumination. I would love to see these in every parking lot, every car dealer that has these blinding white lights. When you go by the car, you know, when it's a very good light. Follow up, yeah. What about automobiles? Well, I've been working on street lights because they are the primary offender. I don't know what I can do about automobiles. One certainly could do this for automobiles. There's a trend in automobiles to go bluer. You've all seen these incredibly annoying, horrible blue lights, 8607, huge amount of light, blind people. Okay, We don't want white LEDs. We certainly don't want that kind of white LED. You get the idea. And so, yes, you certainly could implement these. It's only been the last couple of years that LED technology has gotten to the point where you can efficiently make large amounts of light. The technology has drastically changed. And so, in fact, the lights that I've been working with Philips on this, they are all-American made lights, and they're very interesting. And I see Steph has a question from the virtual audience.
Yeah, a question from Dolly Waywater. Are lights you recommend appropriate in other venues, or are there some situations where they might not be appropriate, perhaps due to weather or other particular characteristics?
These are appropriate almost anywhere I can think of, and what I'm going to show you in a minute is in a weather-sealed box. These are designed to be street lights and take the worst punishment. They're good thermally, and that, of course, depends who makes them. There are a number of products that come from China where they don't do a lot of heat sinking on the LEDs. So without going into a lecture on the physics of semiconductor failure modes, when you have a multi-layer junction in a semiconductor and you heat it up, you will get diffusion of atoms between the layers. And so you've all probably had a computer that overheated and shut off or was ruined, right? Okay, and so thermal management is essential to do this well. So there are a lot of LEDs out there that are very poorly managed thermally and will not last a long time. The ones that I'm going to demonstrate in a minute were made by a company in Silicon Valley, and in years they've never had one fail. And that's primarily due to good quality construction and good thermal management for the semiconductors. So yes, they will go anywhere. Yes? What is an LED? Excellent question. So I said what it means, but I didn't say how it works. And I probably could have done a little physics on that. It's a light-emitting diode where typically you take two layers, a layer of material that has an excess of electrons and a layer of material that doesn't have a lot of electrons. You drive a current through it, and the electrons and the absence of electrons, holes, will combine, and you make light. So it's a semiconductor device. Typically epitaxially grown gallium nitride these days to make the efficient high-power ones. And it's a device that will make light by having electron-hole pair combination.
So it's mercury-free?
Pardon me?
Is it mercury-free?
Absolutely, they're mercury-free. Yes, yes.
What kind of light is
I'm sorry, they're mercury-free, unlike the street lights we're using right now, and unlike mercury vapor lights, and unlike low-pressure sodium lights even. So they're very environmentally friendly in many ways. I'm sorry, yes? Those are also LEDs, and so they typically use, pardon me?
Can you repeat the
Repeat the, okay, the question is what kind of lights are used in computer screens? Yeah, I'm sorry, I haven't been very good about that tonight. In computer screens, they are typically what they call active matrix light-emitting diodes. And they are red, green, and blue. And you get white light, you get blue light, and there are actually a number of studies indicating melatonin suppression from computer screens. In fact, if you're interested in the list that I have, one of those papers that I listed tonight, of the dozen papers, mentions computer screens. Now, that's current computer screens. Old computer screens are what were called a cathode ray tube device. It had an electron beam that was accelerated and scanned in position, and it would hit a phosphor and generate light. When you decelerate an electron, it also radiates, and so the old color TV sets, people were worried about 25 keV X-rays and things like that. We don't have that problem now with modern monitors, but there are issues with modern monitors. Certainly a lot of people are bothered by them. Yes?
What is the color index of the white LEDs? The color reflectivity index? You mentioned that.
Well, reflectivity is a different thing, so maybe you mean the color rendering index. Okay, and so that depends on what type of LED and what the color correlated temperature is. They can be anywhere from 30 to 90. The question is, what amount of blue light is the minimum that you need so you don't do environmental damage, but what's the minimum you need to actually have good color rendition? And so again, the street lights we have now, high pressure sodium, where you have good color rendition, well, reasonably good. That's 24. And so I'm going to demonstrate in a minute a light with a color rendering index of 50.
So more is not necessarily, a higher index doesn't necessarily
If you're a turtle, it's worse. And if you're a bird, it's worse. And if you're a human, it's worse. I think the philosophy here is to minimize blue light, yet satisfy good color rendition and have good quality, even lighting without the environmental impact and without affecting astronomy. And this is possible. Yes?
Using a light for astronomy at night, usually a white flashlight, and you put a red lens over it, you end up with red light coming out. Would it be possible to filter the light coming from the street light rather than change it all colors?
Let's talk afterwards about this. Yes?
What exactly is a Lambertian lens?
Ah, right. I did not define that. So the question was, what's a Lambertian lens, or what is a Lambertian distribution of light? That is a distribution of light that falls off as the cosine of the angle of the light. Let me explain it this way. If I have a circle and I rotate the circle, the amount of area you see falls off as the cosine of the light as well from the geometry. So Lambertian distribution does the same thing, and it makes just a very nice even distribution of lighting that falls off gently. Yes?
What would be the comparative cost of all these different things that you were talking about, thinking of the Maui Council, and what they might pay?
If you add in maintenance, which, again, you have to change these lights often, and I don't want to only emphasize cost because we have some environmental responsibility here, but if you add in maintenance and energy, the LED lights can actually be cheaper.
Just privatize the lights.
That is a way to do it. I won't speak to how the county will handle things like this, but there are a number of ways of doing this kind of thing. Any other questions? Okay, I'm going to give you a little demonstration and a little question, and I'm going to ask you to look at these lights and tell me what you think. And my beautiful assistant will hand out a little test for you, and we're going to look at color blindness and color rendition, and maybe take a bunch and hand them down each end. And Dr. Armstrong will give you a pen, only take it if you need it. I'm going to pause for a moment while these are getting passed out. Now, a word to our virtual audience. The bare filter on the camera undoubtedly is not calibrated. Don't worry about it. This is a human perception exercise. You're welcome to stay on board. Don't be disappointed if you think you're colorblind after this test because you're out in the virtual world. I did not calibrate your camera or your monitor. Does everyone have one of these? Does anyone not have one of these? Okay, let's begin. Thank you for helping with this. This is going to be semi-scientific lighting evaluation. First, would you put down your name, or if you don't care to, you can put John Doe or Jane Doe. These won't be distributed. Would you please put down your age? So I thought we might have, sometimes we have 5-year-olds that might skew the test data. So we want to be able to honestly and appropriately filter the test data. Has everybody put down their name and age? Is there anyone who has not? Great, let's proceed. Okay, so I was really sleepy when I wrote this last night, and I thought this was funny, then maybe it's not. And I talked with my girlfriend about this, but I just took a test last night. I am not colorblind, I am just fashion impaired. So part one of this test, below your name, this is a color blindness test, and please first answer whether or not, to your knowledge, are you colorblind? The answer would be yes, no, or not sure. I don't see everybody writing. See some people. We're all done. Okay. Oh, you're ahead of me. Okay, I'll speed it up. This will only take about 5 minutes here. Great. Now, the next part of the sheet, I'm going to ask you to enter the number you see on the screen, or enter a 0 if you are not sure. Don't feel bad. A good fraction of our population has different types of Deuteronomy and other color blindness, and I don't. So enter the number on your sheet that you will see on the screen. Here's the first one, by number 1. So do not enter number 1. This just means question 1. Okay. What number do you see? Please don't say it out loud. Okay, so to keep this scientific, I don't want you to influence your neighbors. So be good. Be good. Okay, so this is question number 1, and let's zip through this. Question number 1, what number do you see? Okay. Question number 2, what number do you see? Again, 0 if you are not sure.
Not sure or sure?
Put down the number you see, and if you can't tell or you aren't sure, put down 0.
Can't guess.
You can guess. That would be okay. I know you're colorblind.
Half a number.
Okay. Good. So you can put down whatever you want, and if you don't get the right number, I'll know you're colorblind. Okay. Number 3. Question 3. What number do you see? Shh, don't tell anybody. Don't tell your neighbor. Right? Don't influence anybody. We want this to be a scientific test. If you aren't sure, put 0. Is everybody done? Okay. Question 4. What number do you see? They may be. Okay. Don't tell your neighbor that. Okay. So again, if you can't tell or you're unsure, put down a 0. That's no. Okay, I need a proctor for this test. Okay, everybody got that? Okay, for the 5th slot, you know the question? What number do you see? And then you're allowed to use one eye or the other, like you guys are all doing, and you may have the 1% male Deuteronomy anomaly. Can you say that fast 3 times? Deuteronomy anomaly. It's a form of color blindness. Okay, that's number 5. Okay, last one, number 6. What number do you see? You knew that question, right? Is everybody done? Okay, so the second part of this test is going to be different, and I'm going to ask you, JD, to please, Dr. Armstrong, please turn off the back lights. We don't want white light to influence this test. I'm going to, I guess there's no block on this, we'll just, well, I don't want to power it off entirely. There we go. Great, okay. Here we go, you're driving your car. Okay, I have a light here. And so the first question, and so I have a number of cards here. They're black, white, red, orange, yellow, green, and blue. And so I'm going to stand right here. Slot number 1, you have a question? Don't know. And in fact, I made another mistake. It has B for, put a B. Well, there's blue or black, and BL doesn't do it either. So actually spell out blue or black if you can. Okay, so can everybody see this? I'm going to stand over here so it's illuminated. And so I'm using a light here, and so this is number 1. Okay, you ready? This is number 2. Can everybody, you can't see it over there, can you? particularly dark one. Okay. This is number 3. Can everybody write down this color, please? Can you see it over there? You're being blinded by the light because it is going horizontal. It's normally mounted vertically. Is that the problem? Would you? Can you look down here?
Oh, no, I'm fine as long as I've got it.
Okay. Can everybody see this? Okay. That was number 3. This is number 4. Is everybody done with that? Nobody's done with that. Is anybody not done with that? Okay, there we go. Socratic method, interaction, teaching stuff. Number 5. And thank you again for participating in this scientific experiment. Okay, number 6. And try to make it so the light's illuminating it here. Oh, are you getting glare because I'm way downstream here? Yeah, I changed the angle. Is that better? It's worse. It's like that. Okay. I didn't test it out being in the audience. Okay. Number 7 now. This is number 7. Okay. Everybody got it? This is number 8. Please do not write down things like chartreuse, lime. What are those other colors, Therese? Magenta. I don't know what those things are. I know I know color coordinates and spectral wavelength and things like that. Okay, this is number. That was 8. This is number 9. I'm repeating some. I randomized these so as not to influence you. That was number 9. This is number 10. Number 10. Number 10. Number 9. Number 9. No. Number 10. Okay. This is number 11. Don't tell your neighbor. Come on. We'll make it scientific. Everybody gets an A just for filling it out. That's how my classes usually work. Number 12. There you go. Do we have a physicist in the audience? Number 12.
I propose a bonus question.
Okay.
Colors in your shirt.
Bonus question. Colors in my shirt. Yes, bonus. What are the colors in my shirt? Do you see? What color is the turtle? What color? So I have lots of colors in the shirt. Can you see all the colors in my shirt? Okay, so that's the point. And it's my turtle shirt because I love the turtles, which is one of the reasons for doing this whole thing. And I love astronomy, which is also one of the reasons for doing this thing. And I love Maui County, which is another reason for doing this. Okay? And then if you have other questions, feel free to put down in your email there. I'm going to turn this back on. No? Okay, could you please pass all the tests over? And they will be collected by my lovely assistant.
Not so lovely assistant will collect the test.
I'd like to collect them all, and then we're almost done. Please pass them over. Please pass them over. Okay, we got some people who are like checking their answers before they turn them in. Everybody passes. Thank you for doing that. Oh, I meant to show you that. Yes, here's what the test would be like. Okay, so before I end this, I'm just going to give you an opportunity for questions. And before that, in a couple of months, I will be giving you a talk on combined imaging, power generation and distribution, propulsion and communication systems for starships. And so it's a little bit out there topic. It's a result of some of the work from the 100-Year Starship conference that was put on by NASA and DARPA recently, where I was a speaker. And so in about 2 months, probably, I'll give you that talk. So a little plug for that. It'll be a kind of way out, very cool science talk. And with that, I'll say thank you very much, and I'll take any other questions. Yes.
One of the new lights that you were using.
Yes. Oh, I forgot to say that. That is a spectrum compliant light where you can see colors.
What does it look like?
Oh, you can come afterwards and take a look. Oh, it's hiding behind the door. Well, this is a very small version, just for demo. So it looks much like a full cutoff street light. You can make them lots of different ways, and it has LEDs mounted in it and heat sinks. So you can come up afterwards and look at it and talk to me if you wish. Are there any other questions? Yes.
Why didn't we get to see the answers to our exam?
Oh, I could tell you, but I actually just want to tally all of them and compute statistics.
Yeah, but then how will we know if we're colorblind?
I will know if you're colorblind and eliminate. And so, okay, we could do that. I suppose we could have. That wasn't the point. We could do a test, but it was to eliminate you from color rendition testing if you are colorblind. If you are colorblind, then you won't be able to tell what all of these colors are reliably anyway, and so we want to throw the data out of the pool with justification.
So basically, if we thought we were pretty sure and knew what the colors were in the circles, we're not colorblind?
That's right. Well, that's not right, because you'll see different numbers, and in fact, I could tell you if you want to very quickly, I'll do that for you.
Yeah,
I'll do that for you. Let me pull my master here. So it's number 12. Okay, Therese. So, what is the number? What is the number?
3.
Ah, so yes. So you do have some color blindness. So we're going to throw out your test.
Out of 24 pages, I get 1 right, 2 right.
Okay. Number 3.
So I have 70.
Right. Okay. If you don't see 29, you may have a form of color blindness. By the way, everybody could see the first one, 12. Okay. I put in a control. If you got that wrong, you're out. Okay. Number 4. If you said 8, you have some color blindness.
I said 8. Oh,
Okay. Well, in fact, it often goes on the Y chromosome, so you should talk to your dad.
But I'm not colorblind.
Apparently, you may have a little bit of color blindness. Yeah. You may have a little bit. Right. So it's a 5. Right. Okay. The next one. What do you see?
5.
Okay. So you're colorblind.
5, that's fine.
Okay. It is 6. What do you see? What do you got that one? Okay, so we can talk about it, and you have a certain type of color blindness, and there are more extensive tests. This was just to eliminate people from the pool. Okay, so are there any questions? Yes? Yeah, I used the laser printer rather than a McGrath checker chart, and so it was not great on that, and that was the orange. Yeah. And it's not perfect, right? And in fact, we went to get some cards, but we couldn't get all the colors we needed, so this was the backup. You got me. Yes.
So you have this committee for 6 years on Maui, right? Is that correct?
The committee has existed since 2006.
Okay.
I'm now the chair of it and have been for a few years. I was not at the beginning in the committee.
So in this 6 years, what has any result or change or implementation happened?
Well, the way it's gone, that's a great question. The way it's gone is every time they said, let's put in a new light, I said, well, why do you need that? But ultimately, they would often go up. We have no teeth in the committee. We can make recommendations. If there's light within 200 feet, it's pretty clear, no, you don't need it. I at first was saying, no, I don't want any lights unless they're low pressure sodium, but people would not have it. And so that's what spurred me on to go and try to find a good solution like this. And so there's, I don't believe, next time somebody has a light that needs to be approved, I'm going to call one soon to brief them on this. I tried to call one last month, and they said, oh, there's not enough time. They were changing over things. I did invite people from the committee, and I've testified and given most of this talk to City Council so that they are aware of these things with positive feedback. If you think that this is a good thing, then talk to your council member and go, hey, you know, do this right. It's very important. So actually, please do that. Yes?
How many panels were actually black?
I don't know. I randomized them and grabbed some. I did it completely randomly, so I would not even bias you. And in fact, when I was standing back there, I couldn't see what they were either. Okay, so yes.
Is it harmful to look directly at an LED light?
It's harmful to look directly at any ultra bright source. These you can look at, but when they're up high, then they are eye safe. We have lasers in the laboratory that, even though you could look at them, I still don't. And so no more harmful than any other concentrated light source. It depends on the output of the light.
What about a pointer?
A laser pointer? Okay, you've not taken my class before. There were only two ways to fail my class when I taught, and that was to apply the positive data adjustment theorem, which means you kind of make the numbers work. And the other way was to point lasers at people. So your eye has a lens in it. And the lens will focus the light, and you can burn a hole in your retina. And I use 80-watt lasers that'll cook your eyeball like an egg in a split second and blind you in the laboratory. We're incredibly careful with things like this. Laser pointers are not safe. Do not look in the eye. Do not point them at people. Stay safe, you know, on that. Yes?
Well, when you land in the Los Angeles airport at night, you see a sea, tens of thousands of blue lights. Is that what kind of lighting is that? The city is blue.
I have not seen it blue, but I've seen a lot of very bluish light. And so I don't know what they have at the airport, but typically most cities, so airports have some different regulations as well.
No, it's not the airport, it's the city that you fly over and you land.
The answer is I don't know, but I think that's probably high-pressure sodium streetlights.
Which is not good.
That's what we have now, and they have a lot more blue than you need, not great color rendition, and they use a lot of energy. Yes? They will be very shortly. Absolutely. Absolutely. So, in fact, there are a number of companies who are looking at a similar kind of thing. I actually did a design with Philips North American distributor recently. We made some that were actually 20% more efficient than before. And so the answer is absolutely. If you're interested in this kind of thing, come see me or write down your email or something. And so I'm not doing this as a sales thing for lighting. I'm doing this because I care about the environment and stuff. But people have this question: are they available? And the answer is yes. So come talk to me. Any other questions? Yes.
You're retrofitting quite a few lights at the university. Are they talking about this type of thing there?
I don't know, and I sure hope they are. And we have a university person in back here who I hope will carry this back to the provost, who I would have loved to see here tonight. And I would love to sit down with Clyde and have a chat. And the answer is, I don't know. I sure hope they are, and they ought to. They ought to. Any other questions? Thank you all for coming tonight.